Okay, let me just check if I'm live or not. Just a second. Yeah, I think I'm live. Okay, let's start by sharing my screen. Just yeah, I think it is visible now. Let's just see. Yeah. Hmm. Okay, let's read today's problem. Find all k distinct indices in an array. Okay, you are given zero indexed integer array nums and two integers key and k. K distinct index is an index I of nums for which there exists at least one index j such that I minus j is more than equal to k and nums of j is equal to key. Return a list of k distinct indices sorted in increasing order. 1 second. Length. Okay. Mm, Nums. Okay, let me just understand in more depth. It is an easy tag problem, right? Yeah. So I don't think it's much of a problem for me. 3 4 9 1 3 9 5. The value of key is equal to 9 and the value of k is equal to 1. So I have to just add, okay, the ones which are around 9 and the indices which are around 9 and the 9 on which the index 9 is. Okay, so it is going to be 1 2 3 4 5 6, right? Okay, for this so every index, so 0 1 2 3 4. Okay, it's simple. uh, it's very simple. Okay, what I have to do, I have to just keep a vector ARR of size n and initialize it with 0. I'll just explain it what I am doing. Let me just think this idea should work or not, and this approach should work or not. Let me share you the approach. Like it's just like I'm making a visited array of size n, and I'll for each index I'll just create a window of k minus 1 to k plus 1, and I'll check that if it is visited or not. If it is already visited, I'll just move forward. If it is not visited, I'm going to just keep that index into our answer. That's it. Okay. Yeah. uh, One more vector to keep track of our answer. Okay, now for int I is equal to 0, I is smaller than n, I plus plus. Now I'll just keep idx is equal if nums of I is equal to the value of key, then int idx is equal to nums of I, or idx is equal to I. Okay, and int left idx is equal to idx minus k, comma, right, idx is equal to idx plus k. Okay, now what? For int index is equal to left idx. Okay, mm, if okay, uh, I'm going to keep it like this, comma, 0, maximum of this comma 0, because obviously we don't want it to go out of bounds. and for this I want a comma and minus 1. Great. Minimum of these two, right? Okay, index is smaller than n, index plus plus, right? Now what? Just check if visited of index, if already visit, if it is not visited, then only go into this. First of all, mark it as visited. Visited of index equal to 1. Now what? Just add it to our answer. Uh, answer dot pushback uh, I, right, or index. That's it. Now, yeah, do this for every element and return. And here I have initialized this with ERR. Let's make it visited. I think this idea should work. Let me see if it is not working or is there an issue. Oh, okay. I have to write it here. Thought so. Let me see. Yeah, this worked. And let me just submit this code and see. Okay. Uh, what is the value of key? The value of key was 2. Okay. And the window was 5. Okay. Mm, so 1, 2, 3, 4, 5 up to 7. Like, yeah, means why these are also getting added. A minimum of idx plus k comma n minus 1. Yeah, why this thing is coming like this. What is showing this? 06, right? Yeah. Ah, I'm so sorry. Right ideas, bro. But you wrote yeah. Okay, sorry, my fault. Um, right smaller than equal to right idx. That's it. I'm so sorry. That was my fault. Small error. Yeah. No, this should work. Let me see if it is working for long test cases or not. Yeah, it is working for long test cases. Okay. How we are going to optimize this solution, because mm, here we are, what is the time complexity and space complexity of this solution? The time complexity is obviously it is like moving for n times, and also for the window it is k, so n into k. Okay, so in the worst time complexity it is n into k. Okay, and what is the space complexity? Space complexity is O of n. Can we do something better than this? Yeah, we can do something better than this, but let me just think. Okay. Uh, what we can do is we can keep our uh, like the last visited element uh, as a variable of last visited array, last visited element. And whenever we find a number, okay, whenever we find a window, so what we are going to do, If we suppose, let me just explain it with example, okay, with the help of an example. Suppose this is the case, okay. Yeah, suppose this is the case, and the value of k is nothing but this time it was 1. Let's take it as 2. Okay, what I'm thinking, let's keep a variable. Let me just zoom in. What am I thinking? uh, I'll just keep last visited is equal to 0. Initially it is going to be 0, okay. Initially it is going to be 0. As soon as I'll find a key element, the key element here is 9, right? As soon as I'll find a key element, I'll just check which is greater, like the index where this is standing, or the previous index that I am having, like which is the which is more greater, this one or this one. Let's understand in more depth. Suppose this was the array. So I was standing at 0, 1, 2, 3. I was standing at 3. 3 minus 2 is 1. I'll just take max of last visited, which is 0 comma 9 minus sorry 2 minus 3 minus 2 is equal to 1, which is 3 minus 2, which is equal to, by 3 minus 2, because the I minus k. So it is going to give me k, it is going to give me 1. So from this index I have to add the elements till this index, okay. Till this index. Again, I'll just keep my I, or I'll just keep my this last visited as this plus 1, okay. I plus c. I'll just update my last visited is equal to I plus k plus 1, okay. So it is going to be here, correct. And I'll just keep I'll start from here itself, and again if I'll found a element, I'll just start from there itself, and yeah, do the same thing again and again. Great. So yeah, let me just code this approach. uh, I've kept int last visited is equal to 0, okay. And now also we have to keep a vector equal to 0. I is smaller than nums dot size I plus plus. Now what, start from the very first index, and first of all I have to check if nums of I equal to the value of key. If this is the case, just uh, visited is equal to visited is equal to max of last visited comma I minus key, okay. Because if it is going out of bounds, then also it is going to work, and if it is not going out of bounds, it is going to work, okay. And now what, uh, just add everything to our answer, okay. For an element is equal to last visited, element is smaller than uh, element is smaller than, not last visited plus k, it's going to be I plus k. I plus k plus 1, like it is going to be increased till minus 1, that's why element plus plus, okay. Just push back the elements, uh, double r dot push back element, that's it. And one more thing, update the value of last visited. Last visited is equal to uh, I plus k plus 1, and also update the value of I here, because it is important that we don't check the elements again and again. We just check the I plus 1th index. I is equal to I plus k. That's it, and it is going to be increased here itself. So just return the array. Okay, now let me check if this code is working or not. Compilation error a double r dot pushback. Sorry, answer dot pushback. Okay, there is some error. Okay, max of last visited minus k. Okay, let me see. 0 1 2 3 4 5. Okay. mm, I is smaller than int right idx is equal to minimum of n comma n minus 1 comma uh, I plus k. Yeah, great. So it is going to be tell right idx plus 1. Okay, yeah. Now the second test case should work, but the what about the first test case? uh, small initialization of this n is equal to. Okay, okay. This is not the main thing. The main thing is why it is going tell this element. uh, if nums of I is equal to key. Okay, max is equal to last visited, max of last visited comma I minus key. What is the value of I minus key? I is uh, why last visited is showing here, but, but why? That's the main thing. 04. Okay, second test case is not running. Yeah, second test case is correct. Okay, let me just debug the solution. uh, Last visited. I minus key or I minus k? I minus k, bro. Small errors. Yeah, no, I just have written here key instead of k. Okay, let me just submit this code and see if this is working or not. Okay, for some test cases, it is giving me a wrong answer. Uh, Let me see. 46, 47, 48, 49, 50, 51, 930, 939. Where is 939? K square 34. 939 is here. Okay. I plus K. Last visited is correct, and right indexes. Great. Mm, it is in this index. Okay, 939. Ah, okay, okay, okay. I got it. I got it. I don't have to do this. I don't have to do this. You know? Yeah, I don't have to do this. Because see, I'm doing this. I don't have to. Yeah, I don't have to do this because, like, see, I got 939 here also. I got 939 here also. Okay, this idea is not going to work because if I'll just do this and the 34 is coming till here only, and in between I got one more 939, and because of this 939 I should have been mm, I should have iterated till here only, here also. Okay, but I didn't. So here comes play of the visited array. Visited array is important. This idea shouldn't work because of this. So yeah, last solution was the right solution, which I told. So let's just copy the solution because this is the right solution. We should keep track of a visited array, or we just keep a set or anything like that, that will just remove the duplicates and keep the ones which are not duplicates. So yeah,